fourth graders, it is Friday of week 9 and we are still learning about probability. Today's I can statement is I can create a model to represent a given probability. So I will be giving you the probability and you will be creating the model. Today's materials, you will need paper, pencil, and at least 25 blocks of 4 different colors. If you do not have 25 blocks of 4 different colors, it is not a big deal. You can use 25 beads or take a piece of paper and cut it into 25 pieces and color them 4 different colors or write 4 different colors on them. All right, today we are going to first explore a website with some fun probability experiments on it. You can join me using the website or the QR code, or when we are finished, you can come back and explore some on your own. All right, so here we're going to skip intro, go right to the lesson. And since we are learning probability, we're going to do the probability lesson, but there are so many really good activities on here that you can practice on your own. So in this episode, Hank and Chelsea can't choose between heads or tails, so they toss a coin to decide. And we're going to learn about which one is the better one to choose, or is there a better side to choose? All right, so whenever we're ready to move on, it's going to flash this play button and we have to push that.
If I toss this coin in the air, is it more likely to land on heads or tails?
I'm not sure. There must be a way to figure out which side it's more likely to land on.
Let's take a look at probability. That should help us.
All right, so describing probability of an outcome. Clicking play.
Probability is the likelihood of a particular event occurring. For example, we can determine the likelihood of a particular color being randomly drawn from a bag of marbles. Let's put 3 red marbles into the bag. When we draw 1 marble out of the bag, what are all the possible outcomes? Click on the box next to each possible outcome, then click on the check button. You may choose more than one outcome. Clicking on the selected box will deselect it.
All right, so here we have 3 red marbles. There are no blue marbles, only red marbles. So I could possibly get a red marble. I could not possibly get a blue marble. Check the work. Oh, we're correct because the bag contains only red marbles. The only outcome is to draw a red marble.
Complete the chart by clicking and dragging the word that describes the probability of drawing a red marble from the bag.
So we use the terms certain and impossible, and they're using the words always and never. But we know that since there are 3, and they are the only 3 marbles in the bag, that we will always select a red marble, which is actually the same thing as it is certain that we will select a red marble.
When there are only red marbles in the bag, a red marble will always be drawn from the bag. Let's see what happens when we add 3 blue marbles to the bag. When we draw 1 marble out of the bag, what are all of the possible outcomes? Click on the box next to each possible outcome, then click on the check button. You may choose more than one outcome.
All right, so we have 3 red and 3 blue. There are blue in the bag and there are red in the bag. So we could select a blue marble or a red marble. We are correct because there are both red and blue marbles. The possible outcomes are drawing a red marble or drawing a blue marble.
Click and drag the word that describes the probability of drawing a red marble from the bag.
All right, well, since there are red marbles in the bag and there are blue marbles in the bag, we will not always, or it is not certain that we will pick one color or the other. Because there is red and there is blue, we wouldn't select never or impossible. More likely, so that would mean that there were more red and there's not more red. Equally likely, which means that they are the same, each has 3, or less likely would be that red had fewer or less. So I actually need to pick the equally likely because there are the same number of each color. All right, because there are the same number of red marbles as blue marbles, red is equally likely to be drawn.
Click and drag the word that describes the probability of drawing a blue marble from the bag.
Well, equally likely, we've already done that. We already said there are the same. So if red was equally likely, then so is blue. It is equally likely to get red and blue. Because there are the same number of blue marbles as red marbles, blue is equally likely to be drawn.
When there is an equal number of red and blue marbles in the bag, a red or blue marble is equally likely to be drawn. Let's remove 2 red marbles from the bag. Even though there are different numbers of each color, the outcomes remain the same. We will still draw either a red or blue marble from the bag, but the probability has changed. Click and drag the word that describes the probability of drawing a red marble from the bag.
All right, well, we have only 1 red and 3 blue. So it is now less likely to draw a red marble because there are less red marbles. So because there are a greater number of blue marbles in the bag, red is less likely to be drawn.
Click and drag the word that describes the probability of drawing a blue marble from the bag.
Oh, I would say now that there are more blue marbles than red marbles. So blue is more likely to be drawn. All right, and again, we were correct.
When there are more blue marbles than red marbles in the bag, a blue marble is more likely to be drawn, while the red marble is less likely to be drawn.
All right, so now we're going to conduct a probability experiment using marbles. All right.
Now we will conduct an experiment to determine the probability of drawing a blue marble from the bag. Before we do, let's make it more interesting by adding 1 yellow marble to the bag. We must also add yellow as a possible outcome on our chart. Let's predict the probability of drawing a blue marble. Click on the box of your choice, then click on the Enter button.
All right, so let's see. There's 1 red, there's 3 blue, and there's 1 yellow. So there are more blue than any other color. So I would say it is more likely to draw a blue marble. I could say also that red and yellow are equally likely because they each only have 1 marble in the bag, 1 red and 1 yellow. All right, so we're saying that blue is more likely. That is the question to our experiment, and that is our prediction.
For this experiment, we'll draw a marble from the bag 50 times. We'll record the results on this frequency diagram. Each time a marble is drawn, we will record it and then return it to the bag. We'll add a tally to the chart each time a particular color is drawn. We'll then use the tallies to determine the frequency or the number of times each color was drawn. Click on the Draw Marble button to draw a marble from the bag. Repeat this for a total of 10 trials.
All right, so let's draw our marbles. Blue. All right, so we're halfway to 10, and it looks like red is most likely, or more likely right now. Blue's catching up. Oh, red's pulling ahead. All right, so very close, but right now red has been drawn 5 times, blue 4, and yellow only once. All right, let's see what happens.
To quickly complete the remaining 40 trials, click on Complete the Trials.
All right, so this is some math magic. We ready? All right, the experiment is complete. So let's look. So when we only had 10, red had the most, but now that we've done 40 more trials, now we have a total of 50, we were able to see that blue really was drawn the most times, and then red, and then yellow. So red and yellow weren't exactly equal, but blue definitely was drawn more than the
Take a moment to compare your prediction with the results. Click on Continue when you're ready to continue.
So in theory, because there are more blue marbles than red or yellow marbles in the bag, it is more likely that a blue marble will be drawn. However, in reality, this may not be the case, but for our experiment, it was. But
you can conduct this experiment again to see if the results are different, or you can move on. Click on the button of your choice.
So if you want to see if you could get red more than blue, then you can try on your own. So you can pause the video and do it on your own if you're following along, or if you want to come back and you want to try it a few more times, you can, but we are going to move on to the next one. So now we're going to conduct a probability experiment using a spinner.
Let's conduct a different probability experiment. This time we will determine the probability of spinning a particular number on this spinner. First, we must determine all of the possible outcomes of spinning this spinner. When we spin the spinner, what are all of the possible outcomes? Click on the circle next to the answer of your choice.
All right, now this one, my choices say the spinner will stop on 1, 2, or 3. The spinner will stop on 1, 2, 2, or 3. The spinner will stop on 1, or the spinner will stop on 3. So my spinner is labeled 1, 2, 2, and 3. So I definitely know it will stop on 1, and it could stop on 3. But 2 gets a little bit tricky because there are 2 2s. But 2 is the only other original number, even though it appears twice. It is only the number 2. So if I land on 2, I would just put a tally mark. It doesn't say upper 2 or lower 2, it's just the number 2. So there's only 3 possible outcomes here, 1, 2, or 3.
Let's predict the probability of the outcomes. Click on the box next to the prediction of your choice. Then click on the Enter button.
All right, so let's see. The spinner is more likely to stop on 1. Well, 1 is the smallest piece, so I don't think I would say it is more likely to stop on 1. So that's not my prediction. Spinner is more likely to stop on 2. Well, 2 has 2 spots, and it covers about half of my spinner. That's probably going to be more likely. The spinner is more likely to stop on 3. Well, 3 has a big piece, but it doesn't cover as much space as the 2s cover. Or are they equally likely? Well, they're not all the same size. So 2 covers the most space on my spinner. So I think 2 will be more likely to be landed on. All right, so our prediction is being saved, and now we're going to
For this
our
experiment, we'll spin the spinner 40 times. We'll record the results on this frequency diagram. To speed things up, we'll give you 5 identical spinners. You will have to keep them all spinning until you have run a total of 40 trials. Click the spin button for each spinner. Repeat this until you have run a total of 40 trials. You can spin all of the spinners at the same time.
Okay, so that's a lot of times. So we're going to get all these spinners going, and we're going to try to get to 40. What I'm going to try to do is stop at 20 and see where we are halfway. 19, 20. All right, so halfway, 2 has been spun 13 times, 1 was spun once, and 3 was spun 6 times. So halfway, our prediction is true. 13 times we have spun the number 2. So let's see when we do the next 20 if 2 keeps the lead like we predicted. Kind of fun. All right. Oh, it was very close between 2 and 3, but 2
Take a moment to compare your predictions with the results.
was
Click
more
on
likely
Continue when you are ready to continue.
The most. All right. So in theory, because 2s cover more of the spinner than the 1 or the 3, it is more likely to stop on 2. However, in reality, the results might be different. And this was pretty close. So I feel like if we tried maybe
Let's try the experiment
time,
again. This time you can choose the spinner you would like to use. If you want, you can use the same spinner that we just used. Click on the spinner of your choice.
So this one would be interesting to do again and see if we still got 2 the most, because 3 was so close. This one, it's the same. It could be a 1 or a 2. This one, they're all the same. And this one's pretty interesting because there's a lot of 1s. So on your own, you can pick any of these. You could try the same one again, or you can try a different one, or you can try all of them. I'm going to pick this one.
Click on the box next to the prediction of your choice. Then click on the Enter button.
All right, so my outcomes, it could be 1, 2, 3, 4, or 5. There's 1, 2, there's 1, 3, there's 1, 4, there's 1, 5, but there's 1, 2, 3, 4 1s. So 1 is more likely. I feel like that's going to come up a lot more, but I'm also interested just to see if 2, 3, 4, and 5, because they all have equal space on the spinner, will they be spun an equal number of times? So we'll look at both results when we're finished with our experiment.
Click the spin button for each spinner. Repeat this until you have run a total of 40 trials. You can spin all of the spinners at the same time.
All right, so we're going to try and stop at 20 again and see where we are halfway. I feel like I'm on a game show, spinning all the spinners. All right, so 1 has been spun the most, which is what our prediction was. We predicted that the other ones would probably be equally likely, but it doesn't look like that. 2 and 3 have been equally likely, but 4 and 5, 4 has been spun 4 times and 5 has been spun 5 times. Let's check after we finish our experiment now. Getting all the spinners. Okay, so let's look. 19 times for 1. 2 has been spun 4 times, 3 has been spun 5 times, and 4 and 5 have both been spun 6 times. So they're pretty close to being equal. And 1 was definitely spun the most.
Take a moment to compare your predictions with the results. Click on Continue when you are ready to continue.
So same thing like the last one, because 1 appears more often on a spinner. In theory, it is more likely to stop on 1. However, in reality, the results might be different.
Click on Repeat to try this experiment again, or click on Move On to continue.
So this was a fun one. So you could repeat and pick a different spinner and try all the different spinners and see how they all work out. We're going to move on so we can see the rest of our experiments now with the coin. So our conclusion.
Now we know enough about probability to determine whether the coin will land on heads or tails.
When the coin is tossed in the air, is it more likely to land on heads or tails? Click on the circle next to the answer of your choice.
All right, so is it more likely to land on heads or tails? A coin only has 2 sides. It has a heads or a tails. So it is equally likely because they have the same number of sides.
Just for fun, let's toss the coin. You can guess which side it will land on. Click to choose heads or tails. Then click on the toss button to toss the coin. Repeat this as many times as you want. Then click on Continue.
All right, we'll do it. Let's try it 10 times. All right, looks like heads. Total number of. Oh, there's 1 heads. Oh, wow. 2. All right, so it should have been 5. It should be half of what it was. It should happen 5 times for heads, 5 times for tails. It was only 4, but I think if we tried maybe 50 times, it probably would get closer. So the more times we try, the closer we should be getting to our prediction of our theory using our probability. All right, so if you'd like to try more, you can. We're going to continue back to our lesson so that we can move on. So remember, you can go to this website on your own. After the video, you can pause and continue to explore. We're going to continue with our probability for today. So our activity today is that we are going to plan an experiment so that a red block will be more likely to be chosen when picking a single block out of a bag. All right, when you are finished with all of the questions to this activity, you can go to the Flipgrid. Here is the QR code and here is the web address. And you can share the experiment that you made and how you tested it. And it came out that you had red more likely being drawn. And did that really happen when you did your trial? All right, so the second thing now, number 2, place at least 25 blocks. And if you don't have blocks, whatever you're using as a substitute is fine, of 4 different colors in a bag. Record the number of each color of block below. I place blank blocks in the bag. I want red to be more likely to be drawn, so I put in these blocks. So which blocks did you put into your bag? How many and what color? So you can pause the video here. You can make this on your own, or you can go to the resources and print this. Here is my example. So I placed 30 blocks in the bag. It says at least 25. So could I put 100 blocks? I could. Can I put 4 blocks? No, because it says at least 25. So I placed 30. So 20 of my blocks were red, 2 of my blocks were green, 3 were blue, and 5 were purple. Does it have to be those 4 colors? No, whatever colors you're using is fine. All right, so now you're going to draw 1 block from the bag and record the color of the block chosen in the frequency diagram below. Put the next step, put the block back into the bag. Continue drawing a block from the bag and recording the result until you have completed 30 draws. Remember to put the block back into the bag after each draw. So you're going to write the colors, and as you draw them, you're going to put your tally mark over here. Then you're going to use the data you collected to explain the results of your experiment. Were your results what you planned for? A red block will be more likely to be chosen. Explain why or why not using the language of probability. All right, and here is my example. So I did the experiment, and I had red, I drew 15 times. Blue, I drew 3 times. Green, 8 times. And purple, 4 times. So I used the data, and let's see, did I draw red the most? Was it more likely to draw red? Yes, I planned that the red block was most likely to be chosen. I had the most red in my bag, and it was more likely to be chosen. All right, now number 6, explain how you would change the experiment so that a red block would be less likely to be chosen from the bag than any other color. So how would you change it now? Explain why you made this change. Explain how you would change the experiment so that a red block would be equally likely to be chosen as a block of another color. Explain why you made this change. So we started with red being more likely. Now we're flipping it to being less likely and then to being equally likely. All right, so here's so I said that I would put 2 red blocks in the bag. So I would have 13 green, 8 blue, and 7 purple. So 2 red would be the smallest number, so it would be less likely than any other color to be drawn. And 2 plus 13 plus 8 plus 7 still gives me 30 blocks, just like I started with. But I wanted to keep 30 blocks in the bag, and I needed red to be less likely to be picked, so I needed red to have the fewest blocks in the bag. Now I want red to be equally likely as another color. So I would put 10 red and 10 blue, 8 green and 2 purple. So explain why you made this change. So I made the change because I wanted red to be equally and blue to be equally likely because they have the same amount of blocks in the bag. All right, so now you're going to go ahead and create that on your own. So you can print that sheet, or you can go back through and pause the video to answer those questions, and then please share your results and what numbers you used. Please try using different numbers than what I used and share it on Flipgrid so we can see how awesome you have done this week with your probability. All right, I can't wait to see your videos, and thank you so much for coming to do our probability lesson today. I had a lot of fun with that website, and I hope that you go back and you use the QR code or the web address and you practice some of those math skills, because that website was very fun. All right, well, have a great weekend, and I can't wait to see your videos.